Hi everyone, this is Mrs. J, and today we're going to learn how to solve absolute value inequalities. So before we get started, I have a quick little warm-up for you, so please pause the video, give them a try, and then hit play when you're ready to check. Alright, so go ahead and check your work. So here we were solving two absolute value equations. So remember, isolate your absolute value, which you should get absolute value of 2x minus 1 equals 3. Create your two separate equations, one for positive 3, one for negative 3, and finish solving. For part B, when you go to isolate, you should notice that we get absolute value of 3x equals negative 8. The result of an absolute value should always be positive, so this answer does not exist, so we write no solution. So today we're going to learn two different ways to solve an absolute value inequality. And the first, we're going to do it graphically. So we want to know when the absolute value of x plus 3 plus 1 is greater than 4. So we can graph this part of the equation, and then we can graph 4, and we can see the areas where this part is larger than this part. So we're going to be graphing two separate equations here. Let's graph y equals the absolute value of x plus 3 plus 1. So remember, this has a vertex at negative 3, 1. So here's our starting point. And then our a value is 1, so it has a slope of 1 moving to the right. So it looks like this. And then an opposite slope moving to the left, like this. And now we're going to graph this part of the inequality when y equals 4. So remember, this is just a horizontal line at y equals 4. So it looks like this. Okay, so now we want to know when this blue part of our equation, when the absolute value part is greater than the red part of our equation, the horizontal line. So we're going to look at the two, and I'm going to highlight the times when the blue graph is above the red line. So it is above our red line, everything here and everything here. So these regions are our answers, so now we just need to find a way to describe them. So first we need to describe this region. So this region, again, it needs to be in terms of x, because technically we're solving for x, is everything negative 1, 2, 3, 4, 5, 6. So it's everything to the left of negative 6, which would be x is less than negative 6. And then since our answer is split up into two separate regions that are not connected, we're actually going to write the word or, because it can be this region or this region. So this part to the right is everything 0 and to the right, so that would be when x is greater than 0. So here's our solution. Okay, let's try another one together. So again, we're going to graph this part and this part separately, and then we're going to look to see when this absolute value part is less than the 1. So let's start with the absolute value. So we'll do y equals the absolute value of x minus 2 minus 3. So this has a vertex at positive 2, negative 3. So if this is still a little tricky, make sure you go back and rewatch my video for graphing absolute value functions. So opposite, same. So 2, negative 3. And then that a value is 1. So again, it follows the slope of positive 1 moving to the right. Do make sure your graph is exact. And then negative 1 moving to the left. Okay, and then we're also going to graph the line y equals 1, which is the other side of our inequality. So that's just a horizontal line at 1. And then this time we want to see when the blue portion of our graph is below the red portion. So that would be this region from here to here. So that's the time when our absolute value portion is below the horizontal line. So this, you'll notice, is a single region that's bounded between two values. So we can actually write this as a single inequality. We start with the lower boundary. So here this would be negative 2. So we say negative 2 is less than x, and then we say is less than, and then we hit our upper boundary, which is 2, 4, 6. And this is our answer. Again, the only reason that we're just doing less than and not less than or equal to is because the original inequality has simply less than. So again, it's everything from -2 to +6. All right, at this point, go ahead and pause the video, give this one a try on your own, and hit play when you're ready to check your answer. Okay, so you can see here that I graphed y equals the absolute value of, or 2 times the absolute value of x, has a vertex of 0, 0, and a slope of 2 going to the right. And then I graphed y equals 6 in red. And then in this problem, we want all of the times when our blue graph is below our red graph. So that would be everything between -3 and +3. So we can write it as a single inequality, and we will say less than or equal to because the original inequality has the or equal to as well. Okay, I'm going to have you try one more of these on your own. So again, pause the video and give it a try, and we'll check your answer in just a few seconds. So again, check your answer. So here you can see the graph for the left side of our inequality, and then we have the graph for the right side, and then again we want all of the times when the blue is below the red. So it's this little region here, which is everything between -2 and 2, not including because of the original inequality. So now we're going to learn how to solve absolute value inequalities algebraically, so just a different way of doing it. So the first step is similar to solving an equation. We're going to isolate the absolute value expression. So we do that by moving anything that's not inside the absolute value. Now step 2 and 3, it's going to depend on how your inequality looks. So if your absolute value is greater than some number, some positive number, this is actually going to turn into an or situation. So anytime the absolute value is greater than, it becomes an or problem. So we set up 2 separate inequalities. We set up one which is exactly the same with no absolute value signs, and then we set up an opposite. So notice we have a -a, and when we do that, we also need to flip our inequality symbol. So the way I remember this is when we see greater, think of great or means or. Greater means or. Now, if you have a situation where your absolute value is less than a positive number a, then we end up with an and situation. So we are still going to create 2 separate inequalities, but it's going to be an and situation, and you're going to end up with an equation, or you're going to end up with an answer that looks like this. It's going to be bound between 2 numbers. So less than means and, great or means or. So you just need to keep track of which one we'll be setting up. All right, let's give this one a try together, and hopefully it'll make a little bit more sense once you see the process. So again, we're going to start by isolating our absolute value. So absolute value of 4 minus x is greater than 6. So here, since our absolute value is greater than 6, this is going to become an or inequality. So we're going to set up 2 separate inequalities, just like we do with the equations. So one becomes 4 minus x is greater than 6, exactly the same without your inequality. And then we say or 4 minus x, and then we're going to flip the inequality sign and make the 6 negative. And now we're going to finish solving for x. So here we can subtract 4 from each side. Negative x is greater than 2. And then we're going to divide both sides by -1. Remember, when you're working with an inequality and you multiply or divide by a negative, as we are here, you do need to flip the inequality symbol. So we end up with x is less than -2. or, now let's finish solving the other side. So subtract 4. So negative x is less than negative 10. Again, here we're dividing by a negative, so we need to flip the inequality symbol, and we get this as our answer. So graphically, if we were to graph this on a number line, here's negative 2, here's 10. So it's everything less than negative 2, not including it, or everything greater than 10. So you can see here, since it's in two separate regions that aren't connected, that's why it's an OR problem. Now let's try another one together. So here, again, our first step is always to isolate. So we can start by adding 10 to both sides. Now here, since our inequality is less than 8, this is going to be an AND inequality. So we can still set up two separate inequalities here in the same way. So it's going to be x plus 4 is less than or equal to 8, and x plus 4, then we flip the inequality sign, is greater than or equal to negative 8. So let's finish solving. So x is less than or equal to 4, and subtract 4 from each side, x is greater than or equal to negative 12. So this we can actually combine into a single inequality. Just to help you visualize, here's negative 12, here's 4. So it does need to work for both of these. So this says when x is greater than or equal to negative 12, so we start here and we start going in the positive direction, and it has to be less than or equal to 4, like this. So since it's bound between these two numbers, as you can see here, we can write it like this. Negative 12 is less than or equal to x is less than or equal to 4. And there you have it. All right, go ahead and pause the video, give this one a try, and hit play when you're ready to check. All right, so go ahead and check. First isolate, and then again here it says our absolute value is greater than 3, so it becomes an OR inequality. So you set up two different ones. Make sure you've flipped your inequality symbol for the negative version, and then finish solving. So we get x is greater than or equal to 10, or x is less than or equal to 4, which looks like this graphically. So everything below 4 and everything above 10. So you can see two split regions, which is why it's an OR inequality. All right, here's the last problem of the video. So please pause again, try it on your own, and we'll check your answer in just a few seconds. Okay, so here our absolute value is already isolated. So we can look at it and say the absolute value is less than 5. So since it's less than, it's an AND. So you set up the two separate ones, make sure you flipped and made it negative, and then you should end up with x is less than 1 and x is greater than negative 4. So since it's bound between these two regions and it's an AND problem, we should write our final answer as a single inequality. All right, that is all for today's video. Thank you so much for watching.